Website Testing and Deployment. About this course. Welcome to the Website Testing and Deployment course. In this course, you will explore how developers thoroughly test websites to ensure a great, reliable, and responsive user experience. You'll learn about managing website changes with version control systems, publishing a website, using continuous deployment and continuous delivery, and applying the development operations, DevOps, approach. You'll also learn about the services and tools web developers use to test and automate the deployment of their websites to servers or the cloud. Learning objectives. After completing this course, you should be able to identify different types of website testing and the areas to test. Describe the advantages of automated testing. Explain version control systems for web development. Identify the steps to publish a website. Differentiate between continuous delivery and continuous deployment. Describe the purpose, benefits, and workflows in the DevOps lifecycle. Describe responsive design and its importance. Explain delivering web content as a website. Explain delivering web content in a web application. Differentiate between containers and virtual machines. Identify methods and common tools to test and automate the deployment of websites. Explain cloud computing for web development and deployment. Explain containerization for website development and deployment. About this module. Module 1. Website Testing. Introduction. In this module, you'll get an overview of website testing. You'll explore the different types of tests developers perform before they launch their websites and the different areas that need testing. And you'll get an overview of the typical testing process and how automation can simplify the process for larger systems. Learning objectives. After completing this module, you should be able to describe the purpose of website testing. Differentiate between the types of website testing. Identify the areas of a website to consider during testing. List the typical steps to test a website. Describe the advantages of automated testing. Introduction to website testing. Trying to use a website that doesn't work well can be very frustrating. This is particularly true when you need to do something quickly or do something important. When you need to check store hours or when you need to transfer money into your online banking account, you expect the websites you rely on to work properly. Web developers can create a great user experience by doing extensive testing. Testing is critical when developers launch a website, when they make major changes like adding a new feature to a website, and even when they make a minor change like updating the behavior of one button on a web page. How do web developers test their sites to ensure users have a great experience? You'll find the answers to these questions in this module. First, website testing isn't that different from software testing in general. Web developers test the user experience as well as the code they write. Application developers who develop an application that works only on a laptop or personal computer rely on the user interface to be consistent. With desktop applications, the range of screen sizes is somewhat predictable, and laptops and desktops typically use a keyboard and pointing device. Web developers don't have this advantage. A user might experience a website on a desktop computer or a mobile device, and they use everything from a physical mouse and keyboard to their finger for navigation. Looking for bugs. Web developers spend time trying to find software-related flaws, such as bugs. Bugs are flaws in code that can cause crashes or make a site or its features work in a way that isn't intended. They require workarounds or code changes. An important part of the web developer's role is to find bugs in their code and eliminate them. And testing helps them do this. A laptop with a 404 error code is displayed on the screen. Image source, photo by Eric McLean, opens in a new tab. On Unsplash, opens in a new tab. Not all flaws are code-related bugs. Some flaws result from the website's design, and others have to do with the user experience. Web developers examine all areas of a website experience to ensure that the site is operating as they designed it to operate. Types of website testing. There are many different types of website tests that web developers and testers perform, each with specific objectives and strategies. Explore each of these types and learn about their similarities and differences. Acceptance tests. These tests check whether the whole website, client, and server works as intended. Individual website users or teams of users typically perform this type of test at the end of a project just before the launch. Integration tests. These tests ensure that the website's components and functions work together as they're supposed to. For example, a developer might run a series of tests to ensure that the client can make application programming interface (API) calls to the server and that the server sends the proper response back. Unit tests. These tests validate that a specific feature or behavior of the website performs as expected. A unit is the smallest testable part of a website. For example, developers might run tests on a drop-down menu on their web form to make sure it opens and closes properly and contains the right data. Functional tests. These tests check the behavior of the website by simulating real-world scenarios based on the initial requirements for the site. Closed-box testing is a common way to verify behaviors. The idea behind these tests is to see how the website behaves as if real users were using the site in actual business and personal scenarios. Performance tests. These tests show how the website performs under different levels of stress. Load testing, for example, evaluates performance under real-life load conditions. An example of a load condition is the number of requests a website can fulfill at a given time. The more requests the site is given, the higher the load. Regression tests. These are tests that check whether new features break or degrade functionality. Regression testing is important when developers modify, change, or add features. When a new or updated feature breaks the website, it is referred to as a regression bug. Stress tests. These tests are similar to performance tests, except they use extreme load conditions to see how much a website is able to handle before it fails. Usability tests. These tests verify how easily a user can complete a task using the tested website. Usability tests will typically have a number of tasks that the testers will seek to complete. Testers will evaluate how well the site enables the testers to complete the tasks. You're learning a lot about testing websites. Check how far you've come already by answering the following question. Areas to test. There are areas web developers must consider when they're testing a website. The types of tests you just learned about apply to each of the areas that a developer needs to test. They include user interface, UI, responsive design, code, application programming interface, API, databases. Note: client-side processes are generated by a user or client. For example, when a user types a web address like https://www.ibm.com into their browser, they send a request to the web servers for that website. Server-side processes are those activities that are done on or originate from a server. Responding to a web request by sending data to the client is an example. User interface. Web developers need to ensure that the user interface, UI, they're developing behaves according to the site's design and requirements. Web developers make sure that a site has an overall design, including where elements appear on a page, how elements interact with each another, the colors and fonts on the site, how colors and fonts change when users interact with elements. Web developers refer to requirements that describe how the site should function. For example, a website that sells baseball supplies should display products and prices. Users can search and find products, see if a product is out of stock, and buy products. The user interface must work for all this functionality. If the website fails to show a product's price, users won't have a great shopping experience. They might leave the site to buy from another shop. Exit course. Website testing and deployment. 100% complete. Course overview. About this course. Earn a credential. Course design. Module 1, Website testing. About this module. Introduction to website testing. Areas to test. Website testing in practice. Quiz. Module 2, Tracking and Managing Code Changes. About this module. Introduction to Version Control Systems. How does a version control system work? Quiz. Module 3, Delivering a Website to Users. About this module. Introduction to Website Publishing. Publishing a website. Introduction to Deployment. Continuous Delivery and Continuous Deployment. What is DevOps? DevOps and the shift-left approach. Quiz. Module 4, Delivering Websites to All Devices. About this module. Delivering web content as a website. Delivering web content to different types of devices. Delivering web content as a web application. Quiz. Module 5, Services and Tools for Testing and Deployment. About this module. Testing Tools and Services. Runtime Tools. Deployment Tools and Services. Quiz. Module 6, Deploying in the Cloud. About this module. What is the cloud? Cloud computing and web development. Containerization. Quiz. Summary and final assessment. You've come so far. Key points to remember. Final assessment. Course completion. Lesson content. Lesson 6 of 32. Areas to test. There are areas web developers must consider when they're testing a website. The types of tests you just learned about apply to each of the areas that a developer needs to test. They include user interface, UI, responsive design, code, application programming interface, API, databases. Note, client-side processes are generated by a user or client. For example, when a user types a web address like https://www.ibm.com into their browser, they send a request to the web servers for that website. Server-side processes are those activities that are done on or originate from a server. Responding to a web request by sending data to the client is an example. User interface. Web developers need to ensure that the user interface, UI, they're developing behaves according to the site's design and requirements. Web developers make sure that a site has an overall design, including where elements appear on a page, how elements interact with each another, the colors and fonts on the site, how colors and fonts change when users interact with elements. Web developers refer to requirements that describe how the site should function. For example, a website that sells baseball supplies should display products and prices. Users can search and find products, see if a product is out of stock, and buy products. The user interface must work for all this functionality. If the website fails to show a product's price, users won't have a great shopping experience. They might leave the site to buy from another shop. Two people look at web app colors and designs on two monitors and a smartphone. Responsive design. Responsive design relates to UI but addresses a particular and important aspect of the user experience. A design is responsive if the user experience adapts to different screen sizes with no loss in usability. A site is usable if every user on every device can access and interact with the content. Responsive design is the standard for modern websites. Web developers must test their websites to ensure the user experience performs equally well on all devices. For example, web developers test how the UI responds in various orientations, a device's alpha, beta, and gamma rotation angles. The alpha angle is the rotation of the device from top to bottom around the z-axis. For example, if you flip your mobile device upside down so the camera lens is at the bottom and the speakers are at the top with the screen facing you, you're moving your phone along the alpha angle. The beta angle is the rotation of the device top to bottom along the x-axis. For example, if you flip your mobile device so the camera lens is at the bottom and the speakers are at the top and by turning the device, the screen is facing away from you, you're turning your device along the beta angle. The gamma angle is movement of the device from front to back, along the y-axis. For example, if your mobile device is on a table with the screen facing you and you flip it over so the screen is facing down, you're moving your device along the gamma angle. This diagram shows you these rotation angles. If you move a tablet to an alpha angle, then the device is upside down, but the screen is not. If you move a tablet to a beta angle, the screen faces away from you. If you move a tablet to the gamma angle, the screen is facing down. Code. Web developers should test all the code they are using on their website. Web developers write a lot of their own code, and they also integrate open source code. Open source code might have bugs as well. A thorough and methodical testing strategy can find issues and bugs. It's important to thoroughly test all website code to ensure that it is free of bugs, secure, and performs well. For example, when a web developer creates a login experience for the web, they might reveal a user's secure password in the code, potentially putting the user account and password at risk. However, in the code in this image, developers have obscured the user's password by replacing it with other characters that only the computer can understand. By testing their code, the web developer ensures this protection measure is happening, and user data is not put at risk. API. When the client-side code of a website calls an application programming interface, API, on the server side, many technical pieces have to work together to make the interaction successful. Web developers test this interaction between the client and the server. When using an API, the client sends data to the server. The server then does the work and sends data back to the client. Web developers test to ensure that the data transfer happens securely and accurately. In addition, many APIs have an interface available on the Internet, which only authorized clients can access. Web developers ensure that their APIs are secure and that people can't break the security measures with bad intentions. This is especially true if the API provides access to sensitive information. Database. Many websites rely heavily on data, so the design and performance of the underlying database are important for a good user experience. While web developers might not design, build, and structure the database, a database administrator usually undertakes these tasks. It is the web developer's responsibility to ensure that the database works well with the website. If a website is hosted on the cloud, the location of a database can impact how quickly data is sent to and received from the website. For example, many cloud computing providers have regions where servers are located. Regions are physical locations for servers and can be hundreds of miles apart. Deploying a web server to one region and deploying the database to another region can greatly impact the website's overall performance because the web server communicates with the database to service user requests. If the web server and database are far apart, this communication will be slower. Testing the performance of a database can help isolate problems like this. You can see there are many areas web developers must test to make sure everything functions properly for users. Take a moment to check what you've learned. Website testing in practice. Why is testing a priority? Quality control is critical in web development. Defects can damage a brand's reputation by leaving users dissatisfied and driving them away. In extreme cases, a bug or defect can degrade other systems or cause serious malfunctions. Testing costs money, but companies can save millions yearly in development and support if they have good testing techniques and processes. Early website testing uncovers problems before a website is published. The sooner that a web development team finds problems, the sooner they can address common issues such as flaws with the site design, flaws in the website architecture, broken or error-prone functionality, security vulnerabilities, scalability issues. Making testing a priority improves the reliability of a website and can positively impact a user's experience. What does website testing look like? The following example shows how the testing process works. Introduction. The specifics will vary, but most companies test their websites using a common process. You should know the typical steps web development teams take to test a website. Step 1. Define the test environment. A website testing environment is a separate version of a website for testing purposes. It is typically a replica of the live website, but it's only accessible to a limited number of people, such as the website developers and quality assurance (QA) testers. This environment allows the website to be tested and debugged without affecting the live website or its users. A website testing environment is an important tool for ensuring that a website functions properly before it is made available to users. Step 2. Develop test cases. A test case is a series of steps that web developers follow to verify that a website is functioning correctly. The goal of a website test case is to identify any issues or bugs with a specific area or function of the website. This typically involves checking the various features and the functions of the website to ensure they're working as intended and making sure the user experience is positive. A test case could include the following and much more. Checking the website's layout and design. Verifying that all links on the site are working. Testing the website's search feature. Step 3. Write and run scripts. An automation script is software code that a software tool runs. A script consists of a series of instructions to automate the testing of a website. These can include tasks such as checking the functionality of the application, verifying that it is working correctly, identifying any errors or bugs. Web developers typically write automation scripts in a programming language and then run them using a specialized testing tool like IBM's Urban Code or an open source tool like Jenkins. Step 4. Analyze test results. After web developers run automation scripts and conduct manual testing, they analyze the results of those tests. The analysis could involve reviewing the test cases and the expected outcomes, comparing these to the actual results that the web developers and tools found, identifying any discrepancies. Developers might also use specialized tools and software to help them analyze the test results and highlight any areas of the website that require further attention. For example, scripts might produce data that developers can open in a spreadsheet. The spreadsheet can show them problem areas that will help them better understand what they need to address. Step 5. Submit bug reports. When web developers discover a bug or issue while testing a website, they will typically create a bug report to document the problem and provide details about how it can be reproduced. A bug report often includes information such as the steps that developers took to reproduce the issue, the expected behavior of the website, the actual behavior that the test discovered. It might also include details such as screen captures or videos to help illustrate the problem. After testing, the web developer submits the bug report to an appropriate team or individual, such as a project manager or a senior developer, who will review the report and determine the best course of action to address the issue. Summary. While not all web developers follow the same process, most web developers include these steps or similar steps to ensure that all users have a good experience on a website and that the website is reliable. The testing process can take a long time, but some testing tools for automation make the process faster. How can automation help? While web developers can manually test small sites, they use tools to automate the testing process for larger systems. Teams use automation to perform repetitive or time-consuming testing tasks that would be difficult or impossible for a human tester to do manually. This can help to save time and improve the accuracy and reliability of the testing process. Automated testing helps development teams save time by allowing the developer to automate repetitive or time-consuming testing tasks, such as checking the functionality of the website or verifying that all buttons on the site work properly. Improve the accuracy and reliability of the testing process by removing the potential for human error. Identify problems or issues with the website that might not be immediately obvious to a human tester. For example, an automated tool might be able to uncover performance issues or security vulnerabilities that a human tester might miss. Implement different scenarios, such as testing a website on various screen sizes. A responsive website should adapt to different screen sizes. Automation can implement test cases that test the website on every screen size and isolate issues that might arise on certain screens. Test different ideas, such as the impact of moving website components into a cloud environment. For example, a website development team might want to move its login processing to the cloud to make it faster and globally available. They can write test cases to test the impact of this change without the development team having to move the code to the cloud. About this module. Module 2. Tracking and managing code changes. Introduction. In this module, you'll learn how web developers use version control systems to track and manage changes. You'll also learn about the various features of version control systems, how they work, and the steps that web developers perform when using version control systems. Learning objectives. After completing this module, you should be able to identify the system that web developers use to track and manage code changes. Describe the features of version control systems. Explain how version control systems work. Describe the steps web developers perform in a version control system. Introduction to version control systems. Large websites can have hundreds, if not thousands, of individual pages created by several teams of web developers over many years. Large teams of web developers need processes and tools to help them track and manage the changes they make over time to a website's code base. What system do web developers use to track and manage code changes? And what steps do they take? You'll find the answers to these questions in this module. Imagine you are writing a project report with a team of fellow students or colleagues before the invention of computers. The team is discussing the best way to create, edit, and track changes to the report. Each time someone changes the document, you have a new version. But how will the team know what version to submit as the final copy? To reduce the amount of confusion during the final editing process, as a team you decide. The report's content, including all new versions of content, will stay in one notebook and be checked out to one individual at a time. Each team member will write in a different color pen so that all team members know who wrote different pieces of content. And each author will put a date next to any changes they have made. Another notebook will contain a change log. Whenever a team member makes a change in the report notebook, they will update the change log with the date of the change, where they made the change in the report, a summary of the change, and why they made the change. Congratulations! Your team has developed its own method of version control. Web developers also use version control to track and manage changes to software code. One of the first version control systems that developers created was the Source Code Control System, SCCS. Its key features include storing all versions of the code together in a single file, stamping the entire content with essential information, including version number, date, and author, using a delta, or change, log to create a record of the details for each modification. Web developers use a version control system because they need to track and manage changes to code to document who made the change as well as what, where, when, and why a developer made the change. Features of version control systems. Over the years, version control systems have become more sophisticated. Today, common version control systems include features that help developers manage files, track changes to work, collaborate with their colleagues, and even deploy their code. Here are some of the features of version control systems. Code repository. Imagine that your entire family writes books together. When one of you has a new idea for a book, you create the first version and put it on the family bookshelf. You put the updated version on the shelf whenever someone changes the book or adds to it. Over the years, the bookshelf contains all the versions of all the books your family has written. Modern version control software systems include code repositories like these fictional bookshelves. A code repository is a software technology companies use to store the versions of their code files. Developers typically use a code repository in addition to storing a website's code on a web server. Collaboration tools. Development teams work on various projects, and they need to collaborate and communicate with one another while writing code. Version control systems foster collaboration by making it easier for team members to work on the same files simultaneously. Modern version control systems have additional built-in collaboration tools. Version control systems allow developers to comment on their work and upload additional documentation, such as README files, to the repository. A README file is a text file that describes the code. It might also contain additional information, such as installation instructions and help documentation. Some version control systems also offer project management tools to help teams collaborate. And some version control systems even have chat or group discussion features that developers can use to discuss new projects, challenges, or ideas. Code deployment. Development teams deploy code when they publish it to the live environment. Users interact with a website in a live environment. But before deployment, web development teams prepare by first publishing their website and all its code to a staging environment. As you can see in the following image, a staging environment replicates or mirrors all the features of the live website. But it is only accessible to the web development team. A staging environment helps prepare a site by helping web developers discover any final issues that they didn't catch in testing. If the website works as expected in the staging environment, web developers will deploy the website to the live environment. Most modern version control systems include continuous deployment tools. Continuous deployment enables web developers to automate some of the tests they need to perform on their websites. Once those tests are passed, the tools automatically publish the site for users to experience. Continuous deployment reduces the time and effort required to get new features to users. Most developers use version control systems every day as part of their workflow. You've learned about version control systems and some of the features of modern tools. In the next lesson, you'll learn how version control systems work. How does a version control system work? Version control systems allow people on teams to work individually and collaboratively on document additions and changes, and then once changes are complete, the team creates one main document. Imagine that 3 chefs are working together to create a dessert cookbook. They want to focus on some classic recipes and find creative but simple ways to modify those recipes for the new cookbook. They want to work together to develop the best version of 3 basic recipes: chocolate chip cookies, mango sticky rice, and gulab jamun. Initially, the team creates a main document with a general outline of the 3 dishes. The initial recipes include ingredients, preparation, and numbered steps. Each chef receives a copy of the main document to experiment. The team agrees to experiment with the recipes independently, making changes and improvements. They also agree to come back together soon to compare notes to figure out what recipes, or combinations of recipes, will make the final cookbook. During the development period, the chefs make changes and record the changes in their own copy of the main document. Finally, the chefs come together. They prepare all the new recipes, test them, and discuss the details of the modifications. They need to figure out which changes they want to accept and use that information to update the main document for the final cookbook. Recipe 1. Chocolate chip cookies. A tray of chocolate chip cookies with a canister of flour. Image source, photo by Lisa Hanley, opens in a new tab. On Unsplash, opens in a new tab. Only one chef ended up making changes to the chocolate chip cookie recipe. She shows her modifications to the other chefs, gives them a sample, and they agree that this new recipe is better than the original. Because she is the only one to make an update, and they all agree it's an improvement, they decide to accept the change. They make a copy of the main document of the cookbook and then add the new recipe to the main document. Recipe 2. Mango sticky rice. A plate with sticky rice and sliced mangoes. Image source, photo by Marcus Winkler, opens in a new tab. On Unsplash, opens in a new tab. All 3 chefs left the mango sticky rice recipe largely unchanged, except for the following. One chef substituted brown sugar for the white sugar in the original recipe. Another chef finished the dish by sprinkling toasted sesame seeds on top. The chefs tried both variations and liked the 2 changes. They make a copy of the main document and then merge the 2 changes from the 2 chefs into the main document. Recipe 3. Gulab jamun. A person cooking gulab jamun over an open flame. Image source, photo by Jaikishan Patel, opens in a new tab, on Unsplash, opens in a new tab. All three chefs make changes to the gulab jamun recipe. One chef uses turbinado sugar instead of regular sugar. One chef uses brown sugar. One chef uses a sugar substitute. The chefs sample all three recipes, and each modification has its positives and negatives. Now they have a conflict because all the modifications affect the same part of the recipe but do so in different ways. The chefs discuss which change they want to accept for the final recipe. When they decide, they make a copy of the main document and merge the modifications from the chef that used the turbinado sugar. This recipe book example is similar to how version control systems work. Version control systems enable developers to create a main file of source code and then collaborate by working on individual additions and changes to that code base over time. They store the main file and all subsequent versions in the organization's code repository, often known as a remote repository. It's called this because it is not stored on their local computers but rather on their organization's servers or in the cloud. Here's a scenario in which two web developers are working on updates to their organization's website. Take a look at how they use a version control system and the different actions they can take. Step 1. The first step in the version control process is that each developer clones the organization's repository onto their own computer. Cloning a repository is the process of putting a copy of an entire repository on your local machine so you can work locally with the files in the repository. Developers clone a repository so that they can add, delete, or modify code without changing the original main files. Step 2. After each developer clones the repository onto their local machine, they can perform a fetch from the organization's repository. A fetch brings any new changes from the main files into the files on the developer's computer. Step 3. When they have the latest file, they can begin their work. When one developer completes an isolated section of code changes, they will run a commit command. A commit records all the changes that a developer has made since they started working or made the last commit. A commit is like saving a document you are working on so that you can go back later to see what you changed and undo any changes that might have issues. Commits enable you to keep records of what you changed and when. They typically contain a commit message that is a brief description of what the developer changed. Step 4. After a commit, the developers can merge their changes by issuing a pull request. A pull request is a way for the developers to propose changes to a file or set of files in a repository and get feedback on the proposed changes from their team. The code repository informs other team members of the pull request. They can review the proposed changes and then accept, reject, or request further updates to the changes. If the team accepts the changes, the system will merge the changes into the main file or files in the repository. Step 5. Finally, the developers will push their file back to the organization's code repository. A push is a command that uploads the copy of the code file that is on a local machine to the remote code repository. That's the typical version control process. Different version control systems might use other terms for each step in the process, but the main steps that developers take are the same. You've learned all about version control systems. Managing and tracking changes is a key skill for any web developer. About this module. Module 3. Delivering a website to users. Introduction. In this module, you'll learn about the steps to publish a website. You'll also learn about the differences between continuous deployment and continuous delivery. And you will explore the benefits of DevOps, workflows in the development lifecycle, and the shift-left approach in DevOps. Learning objectives. After completing this module, you should be able to identify the process to publish a website, differentiate between continuous delivery and continuous deployment, describe the purpose of DevOps and the benefits businesses can expect, describe the 6 workflows in the DevOps lifecycle. Describe the shift-left approach and its application to DevOps. Introduction to website publishing. Imagine you decide to write a novel. It's been a lifelong dream, and you finally decide to do it. After months of researching, writing, rewriting, getting feedback, and making edits, your novel is finally complete to your satisfaction. You might be satisfied with the process of writing, so you decide to be done with your project. But it's more likely that you'd also want other people to read your work. You'd be ecstatic if others interact with your work and enjoy reading it as much as you enjoyed writing it. To get your novel to other people, you need to complete a publishing process. The word publish is derived from the Latin word publicus, which means public. Put simply, to publish something means to make it available to the public. In the world of websites, people use the term users to refer to the people who will use the website. This is because not all websites are available to the public. For instance, the website might only be for the employees of a company. The main idea of publishing a website is to move it from development to being used by the people that need it. After developers have completed the work to build a website, they need to deliver the site to their users. Publishing a website. Suppose you're talking to some friends and they suggest you throw a party. You like the idea and chat with them about what you'll need for this party. Together, you make the following list: decorations, food and drink, games, guest list, location. To have the party, you need supplies, decorations, food, drink, and games, people, who will come to enjoy your party, guest list, and a venue for this to take place, location. To publish a website, web developers need a similar list of things. They need content and elements the site requires, such as text, images, videos, or games. Users who will visit the site. Technology to deliver and host the website, such as a web server. The content, that is, the text, images, videos, and so on, makes up the website's requirements. Web developers must also clearly define who the users are for the site. This is like the guest list. Some websites internal to corporations serve a small set of users within the company. Hobbyist sites often have a limited number of users, but those users might be spread worldwide. And some developers publish websites aiming to reach everyone on the internet. Finally, web developers need a place to host their websites. In the earlier days of the web, a website might be hosted by a single web server. Today, some corporations still host their websites on their own servers, but many use a cloud provider to host their website in the cloud. This is the location or hosting provider for the website. The process to publish a website. Before a developer can publish their website, they must gather all their content together, ready in one location for users to access it on the site. Explore the following process to learn more about the 3 phases of publishing a website. Step 1. Prepare. Prepare is the first phase of publishing a website. Web developers need to find a location to host their site, either on their own company's servers or on a cloud provider's servers. If the website is going to use a domain name, such as ibm.com, then the web developers need to reserve the domain name and configure it on their servers or hosting provider. Some websites also need to have very specific security measures in place, like a site certificate to enable e-commerce. E-commerce is the activity of buying and selling on a website. Implementing these security measures is also part of the prepare phase. Step 2. Set up. Next, web developers gather all the files required for the website before hosting them at the destination. Many developers use a staging environment to test their website to make sure it's ready for users. Because a staging environment is exactly like the actual location for the public website, developers can use it to identify any last-minute issues. Step 3. Deliver. After all the preparation and setup, developers are ready to deliver their website to their users. This involves copying their files and some configuration settings from the staging environment to the final location. Many developers use tools to help make sure this goes smoothly. If a web development team is delivering their website for the first time, they might need to enable features like their new domain name or some e-commerce features. Developers enable features by making them available for use by the website's users, for example, enabling the domain name to point to the new site. The process of publishing a website can go smoothly when web developers prepare their websites, set up all files required for the websites, and then copy files and configure settings to the final location. You're learning so much. Check what you've learned about publishing websites. Introduction to deployment. You've learned about the typical process developers follow to publish websites. But not all publishing processes are the same. Many web development teams plan for deployments on specific days and publish their site in its entirety on that specific day. In this approach, users don't see the website until the web developers have completed all the work to build it. When it's built, developers deliver the whole website to users. In recent years, website engineers have improved on this approach to publish websites to users more regularly and more quickly. This is called deployment, and it has some distinct differences, improvements, and challenges over publishing a completed website. Imagine your friends message you after you hosted your party to say they had a great time. They also want more frequent get-togethers, even if the parties aren't as big as the last one. This is like the motivation behind modern deployments. Companies need methods and tools to deploy website changes to users more frequently, even if the updates are not big. Continuous delivery and continuous deployment. Many people build replica models to relax and have fun. Some people build models of cars or trains, while others build miniature villages. If you've ever built a model, your first one might not have turned out as nicely as you wanted it to. You had to learn how much glue to use or how to apply paint, so it looks good. With each new model, model builders analyze what they can improve upon and attempt to fix the problems with the next model. Over time, the models look better and better. Improving like this over time is called iterative improvement. The approach attempts to find and address problems on each subsequent build. The early days of software development took the same approach. For some software packages, such as operating systems, development teams would take 2 to 3 years between major releases. Many website developers followed this approach as well. Now that the Internet provides connected systems and tools, web developers can release updates to websites more frequently. Web developers use continuous deployment for today's websites. A collection of changes to a website that are ready for the user is called a build. In a continuous deployment environment, new builds are sent to users frequently, sometimes within days or even hours rather than months. For website testing, a similar concept applies. Development teams will continually deliver updates to the testing environment so they can be automatically tested. This approach is called continuous delivery. Explore more about how continuous delivery and continuous deployment work and see what conclusions you can draw from the processes. Continuous delivery. Website code is developed so that it can be released to the live website at any given time. When specific features are ready, web developers deliver the new and updated code to testers rather than when all features are complete. Web developers create new builds in a continuous delivery environment that are automatically deployed into a quality assurance (QA) testing environment. The automated tests check for errors and bugs. After the code passes all tests, continuous delivery requires that people approve the build and send it into the production environment. For websites, a production environment is the live website that users can interact with. Conclusion: this approach speeds up development because some code is being tested at the same time as other code is being written. Continuous deployment. This is a method for updating websites in which code changes to a website are released automatically into the production environment. It is an automated system with a series of predefined tests. When new updates pass those tests, the automated system pushes the updates directly to the live website. This approach takes automation a step further and removes the need for manual intervention. Conclusion: this approach to updating a website speeds up the time users can benefit from the changes. It eliminates the lag of time between when code changes happen and when users experience the changes. You're making great progress. Take a moment to check what you've learned about continuous delivery and continuous deployment. Continuous delivery and continuous deployment are techniques that web developers use to show changes to users quickly. This helps users to experience bug fixes and new features faster than they would compared to other publishing models. What is DevOps? You might have noticed that publishing a website takes a lot of work. Because there's so much involved, web development teams assign a specific role to manage web deployment. The name for web developers that manage the publishing process is Development Operations, DevOps. Note, DevOps includes deployment work beyond the deployment of a website. Historically, development and operations, and even testing, have been siloed. A work function is siloed when it operates in relative isolation to other functions. For example, can you imagine how chaotic party planning would be if the person in charge of arranging the tables and chairs didn't interact with the person organizing the decorations, and neither of them interacted with the people responsible for the food? DevOps is an approach to deployment that promotes closer collaboration between the business that uses the website, website development, and information technology, IT, operations. DevOps brings functions together to improve and reduce the time needed to address user feedback. With continuous delivery, continuous deployment, and continuous monitoring of applications, teams can respond to users faster and build engaging user experiences. Continuously deploy websites into development, test, and production environments. Scale DevOps successfully without disrupting the business. Ensure consistency from testing to production. Facilitate improved website quality and stability by releasing website features more frequently. Help reduce costs through improved efficiency and reduced outages. The DevOps lifecycle. The DevOps lifecycle consists of a series of iterative, automated development processes, or workflows, within a larger, automated development process. Take a moment to review the following diagram. Notice that it's a repeatable cycle with 6 general workflows: planning, development, integration, deployment, operations, and learning. The diagram also illustrates the continuous process of testing, security, and compliance throughout the DevOps lifecycle. The lifecycle is designed to enable web developers to release high-quality websites quickly. Here are the 6 general workflows that web developers follow in a typical DevOps lifecycle. Planning, or ideation. In this workflow, teams plan what new features and functions a website should have for its next release. They develop these features and functions based on user feedback and by studying how users interact with previous releases of the website. The goal in the planning stage is to figure out how to prioritize which features should go in new versions of the website by creating a backlog. A backlog is a list of features and functions the web development team needs to build. Development. This is the programming step, where developers test, code, and build new and enhanced features based on items in the backlog. Web developers often use their individual computers to write and test the website code before sending it to the continuous delivery system. Integration. In this workflow, new code is integrated into the existing code and tested before it's deployed to the live website. The most common automation activities include merging code changes into a primary code file, checking out the code from a source code repository, testing it, and making it ready for use. Deployment. This workflow involves pushing the new or updated code to a staging environment for testing. DevOps engineers will test for quality and legal compliance. If they find errors or defects, developers have a chance to fix any problems before users see them. Sometimes DevOps engineers deploy an updated website first to a small group of users and then gradually to all users when the engineers are confident it has no major problems. Operations. In this workflow, DevOps engineers monitor the updated website for performance and behavior to ensure that all the target users can access it. This is called availability. Operations ensure that features are running smoothly and that users experience no interruptions. They make sure the network, storage, web server, and security features are all healthy. If something goes wrong, operations identify the problems and notify the appropriate people to fix them. Learning, or continuous feedback. This workflow is when members of the team get feedback from end users and customers on how the website is functioning. They take the feedback back to the website development team for enhancements and features they should consider adding to the next release. This workflow takes the team back to the planning workflow, where they continuously improve testing, security, and compliance. Throughout every phase of the life cycle, team members should be continually testing their changes. They also should be adhering to security guidelines and requirements, and ensure their code meets the compliance requirements of their organization. These are general workflows that web development teams implement. Teams can modify the life cycle by adding or removing workflows. This life cycle has proven to be a model that works well and has helped many development teams create quality websites for their users. See what you've learned about DevOps. DevOps and the shift-left approach. On October 1, 2013, the United States federal government's website healthcare.gov went live with the Health Insurance Marketplace. This is the primary site to support what was, at the time, a new law called the Affordable Care Act. This law was designed to provide affordable healthcare to millions of Americans. While the website has improved tremendously since it was made available to the public, it had problems in its first few months. Many people attributed the problems to inadequate operations. In analyzing problems with the sign-up procedure, Slate magazine noted that the database couldn't process all the requests that were coming in. Slate stated, "This failure points to the fundamental cause of the larger failure, which is the end-to-end process. This means that the problems with the database was only a symptom of a larger problem. The real issues had to do with communication between teams working on the site and how the teams approached testing. There were issues with testing the front-end and back-end website systems. Rigorous testing could have prevented many of the problems the site experienced." Source: Air Engine Down, What Really Went Wrong with Healthcare.gov, opens in a new tab. Slate, by David Auerbach, October 2013. Many websites experience critical failures like the ones the health insurance marketplace experienced. Some involve basic functionality, like not being able to sign up for a service. Others have experienced more crucial errors, such as personal data theft or insufficient credit card security. Screen capture of a list of errors: failed to load resource. Image source: photo by David Pupiza, opens in a new tab. On Unsplash, opens in a new tab. Because of this, DevOps engineers are taking a shift-left approach to testing and other critical operations. The term shift-left comes from the idea that certain workflows in the DevOps lifecycle should be done earlier in the workflow, to the left in a workflow diagram that moves from left to right, and more often. Shifting these items left ensures that the important work is considered first, and testing is done more often rather than leaving them towards the end after all the development work is complete. Here are some areas that DevOps have chosen to shift left or move testing further up in the workflow, so critical operations can get more attention. Continuous testing. Instead of having a single testing phase for a website, developers test code continually. A developer might perform a unit test in which they test the code as it's being written. A peer review might involve another developer examining the code for bugs. Integration tests look for how well the code integrates with other parts of the website. All these tests are done many times, as code is continuously deployed. Security. DevOps strives to incorporate security from the start when security issues are easiest and least expensive to address. DevOps developers then continuously examine the security of the website throughout the rest of the development lifecycle. Compliance. DevOps engineers address regulatory compliance early and throughout the development lifecycle. Regulatory compliance ensures that websites obey all laws that they should. Regulated industries like healthcare and finance are examples where website developers must ensure their site meets certain legal requirements. This requires planning, development, testing, and enforcement of policies as the web developers work on the website. About this module. Module 4. Delivering websites to all devices. Introduction. In this module, you'll learn about how a web browser communicates with a web server to receive website content. You'll also learn about responsive design and considerations for delivering content to different types of devices. And you'll get an overview of how to deliver web content as a web application. Learning objectives. After completing this module, you should be able to explain the process to deliver web content as a website. Describe responsive design and its importance. Explain considerations for responsive design. Explain the process to deliver web content as a web application. Explain considerations for delivering web content as a web application. Delivering web content as a website. Once a web developer creates and deploys a website, it's available for users to access. But how do the HTML, CSS, and JavaScript files get delivered? Users can access web content through a website or through web applications. First, examine the process to deliver web content through a website. Stage 1. Web servers deliver the web content of a website to the browser via the Internet. Web browsers communicate with servers using the Hypertext Transfer Protocol, HTTP. HTTP facilitates requests between the browser and the server to load web pages using hypertext links. Every time a user accesses a web page or performs some action on a web page, the browser submits a request to the server. Because all the code to make the website run resides on the server processes the request and then delivers a response to the browser. A browser's request might include the URL identifying the correct server and resource. A resource can be the web content, specific data in a database, or a back-end tool to run. The method that defines what action the server should take. The actions can include getting a file or adding or deleting some data. Stage 2. When the browser sends an HTTP request, the browser and server start a session. A session is a set of user interactions on a website in each period of time. A web browser interacts with a web server during a session to send and receive data about user interactions. To track a user's activities, the server creates a web session ID and sends it with the HTTP response. For every subsequent request, the browser includes the session ID with the request. During the session, information that the browser sends to the server is saved server-side for easy recall later in the session. Stage 3. Web servers wait for the browser to make the request, process the request when it arrives, and then reply to the browser with an HTTP response. If the response contains an HTML page, the browser renders the page to the user. If the page includes CSS or JavaScript files, or even image files, the browser repeats the process and sends a request to the server to download those files. What do you think? How would you explain the process of how you access web content through a website to a friend or family member? Evaluate your thinking. Does your answer account for the following? You could tell your friend or family member that they must first type in the address of a website that they want to visit. Then, their browser sends a request to a server which processes the request and then sends a web page back to their browser. And the same process happens if they submit a form, such as an order form, on an e-commerce site. Their browser sends a request containing the information from the form to the server. The server processes the request, such as placing their order, and sends a response, such as an order confirmation, back to the browser. You could also tell your friend or family member about how the server creates a session ID on receipt of the first request and returns it to the browser. Then the browser includes that session ID with each subsequent request to identify itself as the same browser. Sessions. Generally, browsing to a website is simple and fast. But there's a lot happening behind the scenes. You might wonder how all of the internet requests get to the right place. To understand this, you need to know a little about sessions, a group of interactions between you and a website. In the following example, explore how ordering a pizza can help you understand sessions. Imagine that you've called a pizza place to order a large pizza. You ask to have the pizza delivered. The person tells you the total amount for the pizza and gives you an order number. When the delivery person arrives, they ask for your name and order number to confirm the order. They tell you the total amount, and you pay for the pizza. The delivery person hands you the pizza to complete the transaction. After you eat your pizza, you visit the pizza place's website to leave a great review of their food. All of these interactions with the pizza restaurant happen in a specific time frame or session. Because you ordered, received, and ate the pizza in that time frame, your interaction with the pizza place happened in a single session. Website sessions are time-based in this same way. Session time frames are set by web developers and are used to create continuity between the server and the client. Classifying interactions as sessions is necessary because HTTP requests are stateless, meaning that each request that the browser sends to the server is independent of any other. The server does not keep a record of previous interactions with a specific browser, and each time the browser makes a request, the server can only handle the request based on the information the browser includes. When a server creates a session ID, it's like the order number in the pizza example. The session ID enables the browser and the server to remember who the user is, what actions they have already taken, and what data the browser and server have sent and received during a specific session. Delivering web content to different types of devices. Whether developers are creating a website or web application, it is important to keep in mind that the users of their website will use many different devices with many different sizes and functions. Developing websites so they are responsive ensures websites look and behave the way they intend on every device their users could use to access it. What is responsive design? You might notice that when you visit websites on a mobile device, the layout changes from what you see on a laptop or computer. The content is the same, and the experience is similar, but there are changes to the layout. For example, some content that the site presents as landscape or horizontal on your laptop screen is presented in portrait mode or vertically on your mobile device. This change to layout is because the site is designed to be responsive. In the following image, all devices show the same image, but the image changes in response to each device's screen size and orientation. A website design is responsive when it adapts its looks to the form factor on which the design appears. Web developers want to make sure their sites look and function well on devices that range from the smallest cell phones to the largest monitors. Web technology like cascading style sheets, CSS, has broad features web developers can use to enable responsive design. Making websites responsive is one way web developers make their sites ready for all devices. Before responsive design technology was available, web developers sometimes designed two versions of their websites, one for desktops and laptops or larger screens and another for mobile devices. Now, responsive design technology allows web developers to build their site once. It will respond to the screen size on which the user is experiencing the site. Building a responsive website doesn't change how the site is delivered. But it does change how the site is developed. Web developers must consider every kind of device that users might use to experience the site. Review the following special content, experience, and testing considerations for responsive design. Content considerations. In a responsive design, some content that works on a laptop might not work well on a mobile phone. For example, if a part of the site uses a diagram with details that are easy to see on a laptop, users might find it difficult to see the details on a mobile device. The web developer can either change the image for the mobile experience or choose to replace the image with just a description of the diagram. Responsive design technology enables developers to make this choice. Here's an example of a web page in which a web developer used responsive design to change how content displays on smaller screens for the IBM Environmental Intelligence Suite, opens in a new tab, Website. Notice in the image of a web page on a laptop that there's a picture with a text overlay on a larger screen. On this screen, the developer placed the text over the image using a white fading effect to ensure the text stands out over the image. The next image shows the same web page but on a mobile device. The screen size on the mobile device is much smaller and the text on the web page is stacked below the picture on a colored background and the fading effect has been removed. Experience considerations. When delivering the same content to devices with different screen sizes and functions, web developers think about how users will experience the site. The web developer can use the following questions to create tests that will help them better understand how responsive the site is. Does the site work well if the user needs to scroll vertically rather than viewing the content horizontally? Does any part of the site require a keyboard and mouse rather than being able to be experienced all through touch? Do images and videos adapt to different screen sizes, or do they get cut off on a smaller screen or are harder to view on a larger screen? Do fonts look good on all screen sizes? Do menus respond to various screen sizes? Here's an example of how the menu on the IBM homepage opens in a new tab, responds to different screen sizes. Notice in the image of the IBM website on a laptop, the menu displays across the top of the screen and shows all first-level menu options as text with a downward arrow. In the next image of a website as it displays on a mobile device, the menu is collapsed into a small menu icon that a user can open to view the first-level menu items. Testing considerations. When developing responsive websites, it's important for developers to continually test their site for responsiveness. This cannot be left until the end of the development process because responsive design must be built in from the beginning. Web browsers have built-in developer tools that enable a developer to view their site in various screen sizes by using emulation. Emulation enables a developer working on a laptop or desktop to use tools that mimic how the website looks and behaves on a tablet or mobile phone. Web developers use these emulation tools to view and test that websites work well on all devices. The following image shows the toolbar from a browser's developer tools. The highlighted area is the tool that will display how the website will appear on various screen sizes. This can be a quick way for web developers to see how their websites will look on different devices. Using frameworks for responsive design. In order to deliver a website that is ready for all users on any device, web developers can use a framework that provides them with tools to make developing a responsive site easier. Frameworks are software packages that include code that integrates into a website. The code can then be used anywhere on the site. It's like installing Wi-Fi in a home. Once it's installed, any device in the home can access and use the Wi-Fi network from anywhere in the house. One popular framework for developing responsive websites is Bootstrap. Originally designed and maintained by Twitter, Bootstrap opens in a new tab, is a free and open-source framework to build responsive websites using CSS and JavaScript. Web developers get a rich set of tools that they can use to ensure their website works well on a variety of screen sizes. The following code example shows Bootstrap in action. In this example, a developer sets a CSS attribute on a div element to use a Bootstrap style called container fluid. This style enables the div element to automatically adjust its size based on the screen size on which the user is experiencing the site. The web developer doesn't have to write the code to enable that behavior, the framework takes care of it for them. Because frameworks like Bootstrap integrate with a website, when the site is deployed, all the files necessary to make the website responsive are delivered to the web server. A framework not only makes it easier for developers to build responsive sites, but they also simplify the deployment. Delivering web content as a web application. You've learned how responsive websites can make delivering a website to users easier by enabling developers to build a single site that works in a variety of device scenarios. Responsive sites work well in most modern browsers. But responsive design also enables developers to deliver web content in another technology called web applications. Web applications are websites that behave like an application and are as robust and feature-rich as desktop applications. In the past, in order to do work that took a lot of graphic or CPU power, users had to download applications that were compiled and run on a device. A compiled application is written in a computer language that developers can understand, which is then translated into a language only the computer can understand before it's delivered to users. Browsers can do amazing things now that previously were only possible from a powerful, installed program. Because of this, software developers can build full applications that can create complex diagrams and run complex spreadsheet operations with sophisticated charts as web applications. Even very graphic-intensive games are possible in web applications. A web application is different than the other program types you've explored because they're delivered entirely online and run in the browser. Many popular apps are available only as web applications. For example, business apps like Miro opens in a new tab, and Lucid Chart opens in a new tab. Web applications have another important feature. Many of them can be installed on a device like a compiled application. These types of web applications are a hybrid between a program that you install on your device through an application store and a web page. The value of web applications. Imagine a chef prepares a healthy meal with 4 main ingredients: carrots and peas as the vegetables, chicken as the protein, a creamy sauce over the chicken, and a side of bread for the grain. People can eat this meal by going to the chef's restaurant where it's served on a plate with a fork and knife. The chef notices people would like to eat the meal on the go or take it back to their office for lunch, but they find it hard to eat in its current form. The chef figures out a way to package the meal, so it's easier to eat outside the restaurant. She chops the ingredients up more finely and makes a pie crust instead of serving bread. She puts the protein and vegetables in the pie crust, pours the sauce over the ingredients, and puts more pie crust over the top. She bakes the new meal in an oven and packages it for takeout or takeaway. It's now a chicken pot pie. A pot pie like this is packaged to be more portable. In a similar way, a web developer can put a website into a package to deliver it as a downloadable app through an app store or from a website. Web developers use an app wrapper to deliver websites in this way. A wrapper is software that functions as a container into which a developer can put a website. As of 2022, there are roughly 6.65 billion smartphone users across the world. That's 86% of the global population. Source: 20 Vital Smartphone Usage Statistics 2022, Facts, Data, and Trends on Mobile Use in the U.S., opens in a new tab, Zippia, October 2022. Considerations for delivering web applications. As smartphones and tablets have evolved and grown in popularity, the emergence of mobile applications has also increased. Developers first developed original mobile applications called native apps. App engineers build native apps using programming languages that interact directly with a device's operating system. Web applications function similarly to native apps, but because the web content in a web application is wrapped in a container, it can run on a device and users can access some of the web content even if they're not connected to the internet. Web application wrappers have interfaces for interacting with the device's operating system. This enables web applications to interact with the device's file system. For example, a photo editing web application that saves photos to your device's photo storage. Web application wrappers enable users to change system settings on their device, such as turning on and off location services and sending notifications to the device. Because web applications are delivered as downloadable applications, they have a broader range of abilities than a standard website. Web developers have special considerations when delivering their sites in this way. Review the following special considerations for web applications. Data considerations. Users can open web applications that they access through an app store or download from a website when they aren't connected to the internet. Because of this, developers might need to include data with the application that would be available on a website. For example, developers should package the text and images that make up the user interface with the app so the user will have a good experience even when working offline. Web developers also need to consider what the app can do if any data is not available. For example, suppose a web developer is making a web application that displays financial data. The developer might decide to store the data the user last viewed and display that data if the user is not connected. When the user reconnects their device to the internet, the app updates the data to the current values. Platform considerations. While platforms like Android, Google, iOS, and iPadOS, Apple, support web applications, the wrappers for these disparate platforms might differ. One platform might support the ability to save files to and read files from the device, while another platform might limit this ability. Developers consider the features of web applications for various platforms and plan their web application features and testing approach accordingly. While a responsive website can be built for all devices, packaging that site into a downloadable web application requires some additional work. Support and maintenance considerations. One design goal for developing responsive websites is to create a single site that anyone on any device can use. This not only provides a consistent experience for users but also can reduce the amount of maintenance and support the web development team needs to provide. It's usually simpler to manage one website and its associated code than it is to manage multiple websites. When developing features for web applications that are delivered through app wrappers, web developers should consider keeping customizations to a minimum. If a developer adds a feature to one platform that isn't supported on other platforms, they diverge from the single site model. And if they do this multiple times across different platforms, they increase the number of sites that they must support and maintain. You're learning a lot. In this module, you've explored ways web developers can deliver their content to users using websites and web applications. About this module. Module 5. Services and tools for testing and deployment. Introduction. In this module, you'll learn about the services and tools that web developers use for website testing and deployment. You'll learn about how they use virtualization services to streamline testing and the many runtime tools they can use to test the performance of their websites before deploying them to their users. Finally, you'll learn about some of the tools and services that web developers use to manage and automate their deployments. Learning objectives. After completing this module, you should be able to differentiate between containers and virtual machines. Explain the ways virtual machines help web developers test websites. Describe different types of runtime tools to test and debug websites. Describe common tools and services used to automate website deployment. Testing tools and services. So far, you've learned about some principles and methods for testing and deploying websites. Testing alone is very important and involves a lot of work. It requires web developers to investigate every aspect of their site. Deployment also takes a lot of attention to detail to do well. Because web development has been evolving for decades, there are a lot of tools and services that help web developers test and deploy their websites to create the best websites they can. Virtualization. When a chef cracks an egg, they usually use a bowl to make the egg easier to work with. If they crack the egg on the counter, it oozes all over the place, creating a big mess. Containers and virtual machines, VMS, are two technologies that web developers use to create runtime environments. When testing a website, these tools can function like a bowl for the egg. When something breaks, they prevent the result from making a mess. Container. A container is a small bundle of software that includes only the parts of an operating system needed to run specific code. To use a container, web developers don't require a full version of an operating system. They just use what's essential to the application they want to run. For example, a web server that doesn't have a graphical interface might use the file system of an operating system but not the graphics engine. Similarly, a gaming application might depend heavily on the graphical and file system components of the operating system, but not use the encryption components. A developer can run a small software application that repeatedly performs one job using a container that includes only the operating system software needed to run that application. This makes the container much smaller than a complete operating system. It also uses less memory, less disk space, and less power. Virtual machine, VM. A virtual machine, VM, is software that mimics an entire computer, both hardware and software. A typical virtual machine also includes an operating system like Linux or Windows. A VM can run inside the operating system of a particular desktop, laptop, or server. Multiple VMs can even run on a single hardware device. Web developers create a VM using a virtual machine software package. Then, they install a full version of the operating system they require and use the VM as they would use any other device. Think about the difference between a large, 18-wheel transport vehicle and a standard family car that you or your neighbors might drive around. You need an 18-wheel truck to get tons of groceries to a market, but you only need your family car to get a few bags of groceries to your home. VMS tend to use a lot of resources and computing power. For tasks such as running a single function for a service, a container might be a more efficient option. Using containers and VMS to control environments. Web developers can set up containers and virtual machines to run their website code in a very controlled way. Suppose a developer is working on a website that handles sensitive financial data. They want to use real customer data for testing, but they don't want the data on a public network while they're testing the website for flaws. They can run the website in a virtual machine that has extra security measures to protect the data while the site is being tested. Developers can also sandbox their applications. Sandboxing isolates a website but runs it in a way that mimics a real-world environment. For example, a developer can sandbox a website and then expose it to a virus and see if the security measures they've developed work to protect the website against the virus. By sandboxing, the developer can isolate the virus, so it doesn't infect other computers on the network. Containers and VMS help create these real-world environments. Using virtual machines and containers can help web developers test their websites in a variety of user environments without purchasing hardware to run those environments. For example, a web developer might run multiple virtual machines, each running with a browser from a different manufacturer. Then they might create another virtual machine running all those browsers alongside each other. Each of these setups will help them test different aspects of their website. Using containers and VMS for clean machine testing. Imagine you've just taken an amazing photo of a sunset, and you want to share it with your friends. You attempt to send a text message with the photo attached, but for some reason, your text message can't be delivered. You want to work out why, so you might go through a thought process like the following. Do you have cellular reception or a Wi-Fi signal? Has your messaging application stopped working? Is the photo too big in file size to send? Do you have too many people listed in the to line? Then you might test if you can send a simple text message to just one friend. Or you might turn off your cellular signal and leave your Wi-Fi signal on to see if the cellular signal is causing problems. What you're trying to do is remove variables. By removing variables, you can better focus on what is causing the problem you're having. Web developers often need to perform tests that have as few variables as possible. Testing their websites on a computer or mobile device that doesn't have other software installed can help with this. A computer that only has the operating system and no other software installed is called a clean machine. It's difficult to create clean machines on physical hardware because it involves erasing the storage media and installing the operating system from scratch. It's much easier to make clean machine environments by using VMS. Some virtual machine software enables developers to create a base drive and a differencing drive. They install the operating system on the base drive and then create a differencing drive for any further changes, such as installing a particular browser. To go back to a clean machine, the developer simply deletes the differencing drive and creates a new one from the original base drive. This enables them to test their website on different browsers without having to install the base operating system each time. Runtime tools. There are many free and paid-for tools that web developers can use to test websites when they're running on a web server. The web server doesn't have to be available to the public, or live, but it does have to enable the website to run as if it were live. Let's examine 3 types of popular tools that web developers use to test and debug their sites. 1. Browser developer tools. 2. API testing tools. 3. Performance testing tools. Browser developer tools. Most modern browsers include an invaluable and entirely free toolset that anyone can use. In browsers based off of the Chromium open source project, such as Google Chrome and Microsoft Edge, the tools are called developer tools. In Apple's Safari, web developers can turn on the Develop menu to see a variety of website development tools provided by Safari. In Firefox, the tools are available from the Web Developer Tools menu item. Here is an example of the developer tools in a Chromium-based browser. Look at the drop-down menu in the image to see all the tools that the browser makes available to the web developer. Each tool provides a way to view the source code of a website, debug problems, and change the HTML of the site while it's running so developers can try different things to see what works and what doesn't. These tools are very powerful and indispensable to web developers when developing and testing websites. API testing tools. You've learned that testing the data transfer and security of API calls is an essential task when building websites. An API for a website exposes ways that web developers can use to retrieve data. Think of purchasing a drink at a coffee or smoothie shop. Many beverage shops have a location or station in the shop to order and pay, and another station in the shop to pick up the drink. At the first station, you're giving the employee information and money. In the second station, you're getting something back from the employee. In the same way, web APIs provide methods that work like the locations at a beverage shop. Some methods enable developers to submit data to web servers and databases through the API. The most common method for submitting data is called the POST method. The most common method for retrieving data is the GET method. A popular tool that developers use to test API calls is Postman. Postman opens in a new tab, has a free-to-use option to get started and offers a variety of features for developers to test and troubleshoot their websites. Developers can create requests that use the POST and GET methods to see how an API responds when they attempt to send or retrieve data from an API. Performance testing tools. How quickly and efficiently a website can deliver content to users directly impacts users' experience on the site. Web developers gain insights into the performance of their website by using a variety of tools that provide indicators on key metrics. A metric is a unit of measurement on a particular aspect of a website's performance. For example, the delay between when a user requests a web page for the first time and when the website delivers the initial data from the site is an example of a metric. This metric is called time to first byte. Most performance testing tools report on similar types of metrics. For example, the metrics that the Google Lighthouse tool for Chrome collects and displays include: First Contentful Paint, FCP. This measures how long it takes the browser to render the first piece of content after a user navigates to a page. Speed Index. This measures how quickly content is visually displayed during the loading of a page. Time to Interactive, TTI. This measures how long it takes a page to become fully interactive. Total Blocking Time. This metric provides insight into the total amount of time that a page is blocked from responding to user input, like mouse clicks, screen taps, or pressing a key on a keyboard. Source, Lighthouse Performance Audits, opens in a new tab, Chrome Developers. Lighthouse is integrated into the Google Chrome browser, but other tools like JIT Metrics, opens in a new tab, aren't browser-specific. In these tools, a developer enters a web address, and the tool produces an extensive report on how their website performs. Some tools also provide recommendations on how developers can improve the performance of their website. Try it out. Opens in a new tab. Now you've learned about some testing tools, you can try using one of them. Complete the following steps to see JIT Metrics in action. Visit https://gtmetrics.com, opens in a new tab. Wait for the site to complete its checks. In the Enter URL to Analyze box, type the address of one of your favorite websites. Then, select Test Your Site. When the test is complete, review the metrics that JIT Metrics displays. Review the top issues it identifies and consider how they align to what you already know about website development. Runtime tools like these are invaluable to developers for providing information about how they can improve their code or site architecture to make the site more responsive. And the metrics these tools provide can help developers discover bugs they might otherwise miss. Now, check what you've learned about runtime tools by answering the following question. Deployment tools and services. After web developers fully test their websites, they need to deploy the websites so users can access them. Developers typically deploy their websites in one of the following three ways. An on-premises deployment, where they deploy the website to web servers that a particular company manages. A cloud deployment, where they deploy the website to a cloud server provider such as IBM Cloud or Amazon Web Services, AWS. A hybrid cloud deployment, where they deploy some website services to on-premises servers and other services to the cloud. For example, a company might store and deliver their website data on their own servers but serve their website content from the cloud. Many tools can support all three types of deployment, but cloud deployment is fast becoming the standard deployment method for companies and individuals. Take time to review the following common web deployment tools, so you're familiar with the tools and services that web developers use to automate the deployment process. Command Line Interface, CLI. Developers can access the features of many deployment tools from the Command Line Interface, CLI. The command line is a tool included with many desktop and server operating systems. The interface of the tool only supports text input and output. As the name suggests, developers use the command line to type in commands and do work or retrieve information. A key feature of a command line is the ability to run a text file containing a set of commands automatically. Developers can even create this type of text file directly in the CLI. In most server operating systems, these files are called batch files. Developers can use the command line to send commands to and get information from deployment tools. Using a batch file in the CLI, developers can automate various steps of their deployment. Here's an example of the Microsoft PowerShell, opens in a new tab, Command Line Interface. Developers can type commands into this interface, like a command to list all the files in a folder, and the PowerShell program runs those commands. Code integration. When working on a team, many web developers will work on different parts of a website. Before deployment and after full testing, the code from these developers needs to be brought together or integrated so all the code works together. Because developers are continually changing code, deployment tools use a feature called continuous integration which regularly brings code together for testing and deployment purposes. Popular code repository GitHub, opens in a new tab, has a range of deployment tools and code integration is a central feature of the site. The IBM Urban Code, opens in a new tab, deployment system also includes continual integration and also supports automating other tools that handle code integration such as the open source automation tool Jenkins, opens in a new tab. Here's an example of a command line tool with a shell command that prints Hello World to the screen. Web developers can use command lines like these to build deployments. Scheduling tools. Web deployments involve continuous integration, continuous delivery, and continuous deployment. Without the ability to schedule when things happen, these ways of developing, integrating, and delivering website code can become complex and unmanageable. Many deployment tools enable developers to set specific times for specific events to occur. For example, a web development team might instruct developers to have all their code ready to integrate at 12:30 p.m. each day. They would then set their deployment tool to automatically start a code integration at 5 p.m. each day and then run automated tests on that code. If the code passes all the tests, the tool should automatically deploy the site to a staging server for further testing. Here's a screen capture of the IBM Urban Code scheduling interface showing the settings available for a scheduled deployment. Blueprinting. In code deployment, blueprinting is the ability to create and view each step in a deployment process. A graphical blueprint shows what events happen at each stage of the deployment and enables deployment engineers to change the settings for a given stage. Web developers use blueprints to better understand what deployment steps will happen and in what order they will occur. For example, IBM Urban Code has a graphical blueprint feature. It can model the resources a deployment will need, which software to deploy on those resources, and the automated processes to run. Developers then just need to ensure that the resources are available, and the website will be automatically deployed. GitHub, similarly, provides the workflow visualizer which offers similar features. Here's an example of the GitHub workflow visualizer. Notice the diagram in the tool that visualizes how the automation will run. This enables developers to more easily evaluate how decisions are made when the automation is run. Cloud-based tools. When developers choose to host their websites with a cloud provider, they can, in most cases, access all the tools they need to deploy their websites to the cloud. Cloud providers also support integrations with other tools to make it easier to use open-source tools with their services. For example, GitHub and Jenkins work with all the major cloud providers, making it easier for web developers to deploy their sites to these services. You'll learn more about deploying to the cloud in the next module. The IBM Urban Code Deployment Tool provides a dashboard view that enables developers to see the status of their deployments and troubleshoot them as needed. The following image shows the Urban Code Deployment Tool that shows the status of each step. In this deployment, some steps were successful and others failed. Developers can then dig deeper into the failures to figure out what needs to be addressed to complete the deployment. About this module. Module 6. Deploying in the Cloud. Introduction. In this module, you'll learn about deploying websites in the cloud. You'll learn about how the cloud has evolved to support every aspect of deployment and the benefits that it provides. You'll also explore how web developers use containers to host some services or entire websites in the cloud. Learning objectives. After completing this module, you should be able to describe the cloud, identify the services that the cloud provides to web developers, describe containerization and how it benefits website deployment. What is the cloud? The first documented use of the term cloud computing was in an internal document at Compaq Computer, which later merged with the Hewlett-Packard Company. Engineering drawings used a cloud as a symbol for a network. Source: Who coined cloud computing? Opens in a new tab. MIT Technology Review, by Antonio Regalado, October 2011. Regardless of the origins, the term cloud generally refers to the Internet. It started as a technical term, but it is now common in everyday language. A cloud computing network with 4 different users, each with their own desktop, tablet, laptop, and monitor. They are all linked to the cloud and have access to various services and storage on it. The cloud, particularly in technical environments, is the set of services and storage that companies and users have come to depend on. For example, back-end web developers might refer to a critical set of website data as being in cloud storage or using cloud services. In this context, they're referring to sites or data that are internet-based. Suppose you are unable to stream a movie or shop online one evening because the internet went down. While this might be an inconvenience, it's unlikely that you'll suffer irreparable loss because of it. But when businesses rely on local systems for data storage and services, failure of those systems might cost them a lot of money in lost business. Using the cloud for data storage and services provides an important backup and recovery system to run their business without interruptions. For individuals, the cloud can provide an extra measure of protection from system failures or data corruption to support essential parts of their lives. For example, you might store critical legal documents on cloud storage. Breaking apart hardware functions. When the Internet was just beginning, companies would use high-powered computers to host web pages and store files. These computers were the first servers. Each computer might have run several websites, and the computer's storage would have all the files needed for the site saved on it. In the early days, it was common for small businesses to have their company's websites running on a server under some employee's desk. Imagine how fragile this was. As internet technology evolved, server farms developed where hundreds and then thousands of servers networked together to share the tasks or workloads involved in delivering hundreds of websites and services. The cloud is an evolution of these server farms. Early internet servers were designed to deliver websites with all the services a website needed, like storage, networking, and security, all on one server. Cloud computing improved on that model by separating the features of one server into distinct functions on specially designed and dedicated servers. This makes it easier for web developers to use only the resources they need when they need them. Today, cloud server farms contain thousands of computers that engineers design for many specific tasks. Some engineers design cloud server farms specifically for large data storage and rapid transfer of that data, including websites. Others build servers specifically to process data. And other servers handle networking or running specialized software. What is the future of cloud computing? As the cloud continues to evolve, the computers that run various services will become more specialized, run faster, use less power, and become easier to maintain. These advances will help the cloud become more integrated into what you do every day. If it isn't already, the cloud truly will be a utility as important as electricity and plumbing. Cloud computing and web development. Some towns have small populations and can support only 1 or 2 stores, like a general store that stocks everything a household might need. In addition to groceries, they carry cleaning supplies, some hardware, and even gifts. Many large grocery stores stock more types of goods beyond just food so customers can get everything they need in one place. Cloud providers work in a similar way, providing all the resources that web developers need in one place. For example, providing development tools, deployment and testing tools, monitoring tools, and the ability to scale to regions throughout the world. The cloud truly has revolutionized web development. It provides web developers with the ideal environment for building websites that impact people's lives. Explore some of the services the cloud provides web developers. Hosting. Cloud services offer many options for hosting websites. Some offer templates for popular content management systems like WordPress and Drupal. Content management systems are software packages that include everything needed to deliver content to users. Cloud providers also host and manage domain names. Replication. Imagine that you need to mail a letter using the postal service. If your letter was going to someone across the town you live in, you'd expect it would arrive much sooner than the same letter going to someone halfway around the world. While electronic signals move much more quickly than letters, they still experience latency. Latency is the delay between when an electronic signal is transmitted and when it is received. The further apart the source and the target are, the greater the latency. Modern cloud services have servers all over the world. They offer replication to automatically copy the entire code base for a website to servers in various parts of the world. Replication helps reduce latency by putting the website code closer to the users. Scalability. In the days before the cloud, if you needed more power on the computer you either had to upgrade your hardware, buy another computer, or borrow one. This was inconvenient if you only needed the extra power temporarily. The cloud helped address this scale problem. Many of the web services available in the cloud enable web development teams to pay for only the capacity and power they use. If a website needs more storage, the web development team pays for it when they need it and can scale back, or pay less, when they no longer need it. Security. When you want to protect your personal computer, you might install a virus scanner or a firewall. Websites need protection, too. People with malicious intent might try to steal data or cause a website to fail. Cloud services include tools that can keep websites safe. For example, cloud services can help prevent denial of service, DOS, attacks. A DOS attack attempts to overload a website by sending enormous amounts of fake requests to its servers so that the website can't respond to real requests. Cloud services can monitor for these types of attacks and either prevent the requests from reaching the website or alert the website owner of the attack. Monitoring. Most cloud services include tools for examining the status of the web services that the web developer is using. For example, a web developer might need to understand how much computer power their site is using so they scale it up if there's not enough power or scale it down if they're using too much. Monitoring tools help developers to see every aspect of their site, from network traffic to the requests the website is receiving. Many cloud services provide a customizable dashboard so developers can quickly see the information on many items essential to their website. Development tools. Most cloud providers include tools that web developers can use to create websites. Some offer tools for creating back-end solutions, such as IBM Vapor, and others provide code editors for front-end and back-end development, like Microsoft Visual Studio Code. Most cloud providers also include a command line interface for troubleshooting, deploying, and testing web services. Cloud services save development time by including a lot of the tools, such as page authoring and plugin support, that many content authors need. Cloud services make it straightforward to deploy and manage these templates. Cloud services also provide all the infrastructure for web developers to build their own sites from scratch. They enable web developers to create web servers, build virtual machines and containers, and write functions. Functions in this sense are software that handles very specific jobs for their website. These are just some of the ways in which cloud services provide web developers with the tools they need to build great experiences for their users. Let's see what you can recall about these services. Containerization. Cloud computing also provides services that enable web development teams to use fewer resources while building more efficient services that scale. This is good for the environment as well as the end user. In this lesson, you'll learn about some of these services. The invention of shipping containers revolutionized trade and logistics by standardizing how shippers moved freight from one place to another. Shipping containers enabled shipments to be moved between different modes of transportation, ship, train, or semi-truck, without anyone needing to unload the goods. Shipping containers can carry a whole range of goods, from grains the size of rice to large cars and machinery, while remaining a standard size. This invention made the cost and time it takes to ship something worldwide decrease significantly. Like a shipping container, a software container is a standardized package. Everything needed to run the program is inside a single container, including the code, runtime environment, system tools, and libraries, and settings. Beyond operating systems. Before containers, developers would need to install an entire operating system like Linux or Windows on a physical computer to run any software that they needed to deliver web pages. They would install their software, such as a web server, and then deliver their website to users. To simplify this process, engineers developed virtual machines, VMS. VMS were like physical machines, but they used software to emulate the physical hardware. An emulator copies all the features of the physical computer in a software application. Developers might then install an operating system on a virtual machine. The challenge with both approaches is that they require the web developer to install and run an entire operating system, even if they only need to use a small part of the operating system for a specific job. Operating systems take up a lot of storage and memory. Storage and memory require disk space and electricity. What if a developer is able to take out only the parts of the operating system they need for their job and use their software with just those parts? And what if they are able to take those parts and run them in a virtual machine? This is what a container does. The benefits of using containers. 1. Containers provide two key benefits to web developers. 2. Within a container, code is no longer dependent on the hardware to run. By putting all the necessary parts of the software in a container, developers create stand-alone and portable environments. They can then deploy containers on several different systems. 3. Developers can use a single container to run anything from a static website, a software process, or a large application. Organizations can even break down larger websites and applications into microservices that they package in containers and deploy on the cloud. A microservice is a stand-alone portion of a website or application that delivers a single capability such as user authentication, recommendations, menus, or search. Take the example of the popular streaming platform, Netflix. Using containers, Netflix can break each specialized function into a smaller, more manageable service. For example, video selection is a microservice inside a container that provides your computer, tablet, phone, or TV with the video file to play. Developers can use container technology for nearly every type of internet hosting, from web hosting to database hosting, and even audio and video hosting. Developers use containers to provide data to the front end. Shipping containers revolutionized trade. Similarly, containerization and microservices have revolutionized how organizations deploy and run programs, from websites to web applications. You've come so far and learned so much. You explored how developers thoroughly test websites to ensure a great, reliable, and responsive user experience. You learned about managing website changes with version control systems, publishing a website, using continuous deployment and continuous delivery, and applying the development operations, DevOps, approach. You also learned about the services and tools web developers use to test and automate the deployment of their websites to servers or the cloud. Now that you've completed this course, you should be able to identify types of website testing and areas to test. Describe the advantages of automated testing. Explain version control systems for web development. Identify the steps to publish a website. Differentiate between continuous delivery and continuous deployment. Describe the purpose, benefits, and workflows in the DevOps lifecycle. Describe responsive design and its importance. Explain delivering web content as a website. Explain delivering web content in a web application. Differentiate between containers and virtual machines. Identify methods and common tools used to test and automate the deployment of websites. Explain cloud computing for web development and deployment. Explain containerization for website development and deployment. Key points to remember. 1. Web developers test websites for user experience and software-related flaws. 2. There are many different types of web tests with specific objectives and strategies, including acceptance, integration, performance, and usability. 3. Web developers should consider the user interface, responsive design, code, APIs, and databases when testing a website. 4. Web developers use version control to track and manage changes to software code. 5. A version control system can include features such as a code repository, collaboration tools, and code deployment. 6. Web developers use the continuous delivery approach to deliver updates to websites so that they can be automatically tested. They use a continuous deployment approach to deliver new builds to users on a regular basis. 7. DevOps is an approach to deployment that promotes closer collaboration between the business that uses the website, website development, and IT operations. 8. The DevOps lifecycle consists of 6 general workflows that enable web developers to release high-quality websites faster. 9. Web browsers communicate with servers using the Hypertext Transfer Protocol, HTTP, which facilitates requests to load web pages using hypertext links. 10. A website design is responsive when it adapts its looks to the form factor on which it displays. 11. Frameworks are software packages that include code that integrates into a website and assists web developers in developing a responsive site. Frameworks also provide code libraries that can handle data management, control the user interface, and handle common tasks like creating and delivering forms. 12. Web developers use an app wrapper to deliver websites as downloadable apps through an app store or from a website. 13. Web developers can use command line interfaces, code integration, scheduling tools, blueprinting, and cloud-based tools to automate the deployment process. 14. The cloud has revolutionized web development by providing services, such as hosting, replication, scalability, security, monitoring, and development tools. 15. A software container is a standardized package of software that contains everything that is needed to run a program.